Hello everyone, welcome back to my channel. I would like to start this video to explain about invertible function. So, invertible function, as we discussed composite of a function in last video. So, when a function is defined f from x to y, then if there exists some function g y to x such that gof is equals to ix and fog is equals to iy, then g is called the inverse of f and denoted by f inverse. So what do you mean by gof is equals to ix? It means gof function is working as an identity function. It means under GOF, if you take image of any member, you will get the member itself. Similarly, FOG, if you take the element, if you take the element under FOG, you will get the member itself. It is also working as an identity. So when f is defined from x to y and g is defined from y to x, GOF will define from x to x and FOG will define from y to y. So if GOF is working as an identity function, then its set would be mentioned as x. So that's why we have written GOF is equals to ix here. In other words, if you understand invertible function, then if a function is 1 1 onto, then only we say it is invertible function. It means a bijection is only an invertible function, as we can understand with this picture again. When I have defined about function, the type of function, then you may have seen this picture. You can see in the first case it is 1 1 into. So if in this case we discuss about invertibility, then in the second set x2, here we do not have the images of ef, right? When you define suppose some function g, if you want to define this g in this picture, if you see, then x2 to x1 we cannot define any g because ef does not have any element, does not have any image under the reverse function. In this case we cannot define invertible function. In this picture number 2, you can see, if we want to define here, if we want to define here the inverse function, again we do not have image of a under inverse of f2. So we say here also function does not have any inverse element. In this picture, if you see, in this picture we have all the elements image, but one person a has two images. So when, if you want to define here inverse function, this function definition only it won't validate because one person has two images. So what was the function definition? All the elements should have unique image. In this case a will have two images, so the function definition won't remain true. It means in this case also we cannot define any inverse function. Now come on this picture, we can see this is 1 1 on 2 case, which we discussed further as a bijection function or bijective function. So in this case every member is related with one only and all the elements of the codomain are related. So when you when you will define the inverse function from x4 to x1, then you can see every element will have the images and unique images, so function would be well defined. So what we can say, only in this case we can define the invertible function when the function is 1 1 and on 2. So basically, to prove any function is invertible function, we will prove whether it is 1 1 on 2, it means it's a bijection, or if we have been given g, then we can prove these two condition also, then also we can say the function is invertible function. So let us take some example for invertible function. It's a question number 4 from your exercise 1.3. You can see one function is given and they are asking show that FOF x is equals to x. So this is a integrated question of composite function and invertibility. So you can see in this question we have to prove FOF x is equals to x. So I have taken fx is this. Now we applied the definition of composite function. We will apply this function first. So fx we applied here, then fx value from the function, the definition of the function we read, and here we put. Now again this will become x. We will substitute this value in the definition of fx again. At the place of x I substituted here, then you will get after solving this is coming x. That's what the first thing you need to prove. Now they are asking what is the inverse of f. So for inverse we prove the case of onto. So let us take some member y in the codomain of f, where here it is not defined, but we take from the codomain in the case of onto, right? Now we will substitute y is equals to this value. Then we will solve this in the case of onto. What we do, we solve this equation. We solve this equation by the we solve this equation by with the help of the we solve this equation in terms of x. So when I solve, you multiplied here, and then we get this case x is coming 3 plus 4y 6y minus 4. This is only the inverse function. Since here we can see this f inverse and f, they are working as similar way. So we say here fog iy we have got, gof ix we have got, then only g is inverse. Now here already fof x equals to x we have proved. It means this f is only working as inverse. So either you can prove in this way by taking by proving it's an onto function, or you can write here fog is equals to iy and gof is equals to x. Since fof is already coming x, then we say it is only the inverse. So here we found the inverse. Now next I will take one more example or invertible function, which is again from your exercise 1.3 question number 9. Now in this case you have been given one function. It is well defined function. Here we have to prove f is invertible with this inverse. So in this case we can go with two manner, right? First, either you prove this function as 1 and onto, and while proving onto you can get the inverse, and prove the inverse you will get the same inverse which is given in the question. Another way you can prove, since f inverse is given, so f inverse we were denoting in invertible function as g, right? As g. So either you prove in the, as g we have proved, so you can prove this condition as well. So to prove this function invertible, we can prove gof is equals to ix, or and fog also equals to iy. Both ways we can go, whether you prove it's a 1 onto function, or you prove this condition. Since g is given, g is nothing but f inverse here. So I would like to explain you this question with both the methods. So first I am proving with the first part, I am proving it is a bijective function. For that I will prove it one. So recall the algorithm which I have explained in my previous video. What we do for 1, we take two elements in the domain. Here in this function domain is r plus, so I have taken two elements x1 and x2 from domain. Right now in the domain, the two elements which you have taken, take their images equal. I have taken their images equal. Then definitely I will put the value of fx1, which I will read from the function definition which is given in the question. Substituted the value of these two function, these two fx1 and fx2, then solve this equation. We have got this equation x1 minus x2 into 9x1 plus 9x2 plus 6 equal to 0. when two number multiplication is equals to 0, either this number 0 or this number 0 or both 0, right? So this algorithm we will follow. So either this 0, x1 minus x2 will be 0, then we will get x1 equals to x2, which we wanted to prove. But let us check the second condition also. If it is 0, it means x1 is equals to minus x2. Some x1 will get the negative of x2, but we have taken x1 and x2 from r plus. It means for r plus it can be never possible, right? So in this case we can say this is x1 is equals to x2. So what do you mean by this? If x1 equals to x2, what we can say? Function is 1 1. Function is 1 1. Now second case we will prove onto. So to prove onto, what we do? We take one element from codomain. Codomain is here minus 5 comma infinite. Please note that codomain is minus 5 comma infinite. So I have taken one member from codomain such that substituted fx equals to y. Then when we substitute this value from the definition of the function, we will solve this equation. What is the next process? Next procedure, we will solve this equation for x. So what I did here, I have made it is a perfect square. For perfect square I have added 1 and subtracted 1. I hope you must be knowing about the method of squaring method, completing the square method, sorry. So y equals to 3x plus 1 square minus 6. We got from here 3x plus 1 square is equals to y plus 6. 3x plus 1 is equals to root y plus 6. In this case, when we proceed, then we get uh, x as root 5 plus 6 minus 1 divided by 3. So what we have seen, f inverse y, we have got this, but we have taken y from this set, right? Codomain. So when I will the very first value I have taken minus 5 here. So definitely root of 6 minus 5 will be 1. So first value you will get 0 here. It means that will be r positive, right? So for every value which you will take from this codomain, f inverse y which you got always will be in r plus. It means for every y we have pre-image in domain. It means it is onto. If it is onto, then this function is only called the inverse function of the given function, right? So this is the one way we can prove that particular function is invertible. So when it is 1 1 onto, as according to the definition, we can say when function is 1 1 onto, function is invertible also. So in this case function is invertible. Next, we can prove this function invertible in the another case also, when f inverse is already given. Now we can use the definition of the composite function. If we are able to prove, that gof is equals to ix here, x is the first set which is r plus, right? And here fog iy is minus 5 to infinite. So here we see I am presenting here x as r plus and y is minus 5 comma infinite. So let me check what is f inverse. If I substitute f inverse as g, so g is only inverse in the according to the definition. When I substitute this value, f inverse f of x, I will get here, after solving you can see, will get x. It means this function is working as identity function. Similar way we will check f inverse o, f inverse x. So we have got this is at the identity function. So ix here, x is r plus, okay? Here x is r plus. Now again we will check fof inverse y. So fof inverse y you will check, then first you will apply f inverse, then when you will solve it with the help of normal mathematics, algebraic mathematics, you can see I substituted this value, squared it, and then this 9 get cancelled with this 9. This 3 will this 6 will get cancelled by 3 by 2. Then 2 multiplied by these two values, you will get this value, right? After solving this, you will get y. So you can see this function also working as an identity function. So it can be replaced by iy, where y is minus 5 comma infinite. So what we have seen in the given question, when we have been given inverse of a inverse of a function, then we can say that f is invertible if that condition, that function is satisfied these two condition. So in this case also we can prove that function is invertible, or function is invertible function, or you can say function has inverse with this. So I hope this video will be helpful for you all to solve the invertible question problems. Thank you all.